The trigonometric identities are equations that are always true. Trigonometric identities allow us to simplify a given expression so that it contains sine and cosine ratios only. This enables us to solve equations and also to prove other identities. The two identities that we're familiar with are sine squared theta plus cos squared theta is equal to 1, which is what we call a square identity. And then we've got a quotient identity, which tells us that tan of theta is the same ratio as sine theta over cos theta. These are very common because you will come across them in many questions that you do in trigonometry. Some useful tips for proving identities are as follows. Firstly, change all trigonometric ratios to sine and cosine if you can. Choose one side of the equation to simplify and then show that it is equal to the other side. It is usually better to choose the more complicated side to simplify. Sometimes, however, you need to simplify both sides of the equation to show that they are equal. A square root sign often indicates that we need to use a square identity. The reason for that is, remember, if sine squared theta plus cos squared theta is equal to 1, we can rewrite this equation in many different ways. For example, we can say sine squared theta is equal to 1 minus cos squared theta. And then, to find sine theta, we can square root both sides and say sine of theta is plus or minus the square root of 1 minus cos squared theta. This is why a square root may indicate to you that we are dealing with a square identity. We can also add to the expression to make simplifying easier. For example, if the expression just had sine theta, we could multiply this by 1 by multiplying by sine theta over sine theta, which would then give you a square in the numerator. So it may be necessary at times, depending on the identity you've been asked to prove, to add to the expression. You could also add something like 1 to the expression, where you can change the number 1 to sine squared of an angle plus cos squared of the same angle. The identity, which you've been asked to prove, determines how you will need to change your expression on either side of the equality sign.